Alright. So I'm sure we've made this clear to you all what is sample and what is population. There are two main types of sampling techniques that I'll discuss today. You have probability sampling and non-probability sampling. Now in this video, we'll only be focusing on probability sampling techniques, because non-probability sampling is not within the scope of this. Right, we'll discuss the probability part because we're focusing on statistics, correct? Under probability sampling, we have three different types. We have random sampling, systematic and stratified sampling. Alright. And just to mention the different types of non-probability sample, we have snowball quota, judgment, and convenience sampling. Alright. Now guys, in this session, I'll only be focusing on probability. So let's move on and the different types of the sample. So what is probability sampling? It is a sampling technique, using the theory of probability. So there are three types of probability sampling. At first we have the random, so, in this method, each member of the population has an equal chance of being selected in the sample. Right. So each and every individual, or each and every object, has an equal chance of being a part of the sample. That's what random sampling is all about. Okay, you are randomly going to select any individual or any object. So this way each individual has an equal chance of being selected. Correct. We have systematic sampling. Now in systematic sampling, every nth record is chosen from the population to be a part of the sample. Alright, now refer this image that I've shown over here. Out of these 6 groups, every second group is chosen as a sample. Okay, so every second record is chosen here. This is our systematic sampling works. Okay, you're randomly selecting the nth record, and you're going to add that to your sample. Next, we have stratified sampling of technique. Kratom is used to form samples from a large population to what is the striatum, or striatum is basically a subset of the shares. Common characteristics. Let's say that your nation has a mix of both male and female. So you can create two straight, and this one will have only the male subset, and the other will have the female subset. Alright, this is what freedom is, basically a subset of the population that shares at least one common characteristics. Alright, in our example, it is gender. So after you've created a straighten, you're going to use random on the straight difference, and you're going to choose a final sample. So random sampling, meaning that all of the individuals in each of the striatum have an equal chance of being selected and the sample correct. So these are the three types of sampling techniques. Now let's move on and look at our next topic, which is the different types of statistics. After this, we'll be looking at the more advanced concepts of statistics. So far, we discussed basic 6, which is basically what is the different sampling techniques, and the terminologies and statistics. Right now we look at the different types of statistics. Major types of 6 descriptive statistics in inferential session, we got both of these types that sticks in depth right. We'll also be looking at a demo, which I'll be running in the ARM, which in order to make you understand what exactly descriptive and inferential statistics is, because we're just going to look at the basics, or don't worry if you don't have much knowledge. I'm explaining everything from the basic level. Right. Descriptive statistics is a method which is used to describe and understand the features of specific data set by giving a short summary of the data, so it is focused upon the characteristics of data. It also provides a graphical summary of the data. Now, in order to make you understand what descriptive statistics is, let's suppose that you want to give all your classmates a t-shirt to study the average shirt is in a cloud. If you were to use descriptive statistics to study the average shirt size of students in your classroom, then what you would do is you would record the shirt size of all students in the class, and then you would find out maximum, minimum, and average shirt size of the cloud. Okay. To inferential statistics makes inferences and predictions about a population based on the sample of data taken from the population. Okay, in other words, realizes a large asset and applies probability to draw a conclusion. Okay. Allows you to enter a parameter-based statistic by using sample data. So if we consider this sample of finding the average shirt size of students in a class, in inferential statistics, you will take sample size of the class, which is basically a few people from the entire class, at all your pad class into large, medium and small, right, in this manner. Basically, there's a Steadicam model, and in it for the entire population in the class, because there was a brief panning of descriptive and inferential statistics. That's the difference between of and inferential. Now in the next section, we'll go in depth about descriptive statistics. Alright, so let's discuss more about descriptive statistics. Like I mentioned earlier, descriptive statistics is a method used to describe an unknown cause of effect by a sample of the party. In this case, we have mega central tendency, which is also known as measure. Yeah, MEL is very, this is also known as measures of spread. So measures include mean, median and mode, what is known as center, as your centers, statistical measures that represent the summary of a data set. Okay, the three measures of mean and more coming to measure, do metals, spreads, half-inch salary, variances, and standard deviation. Alright. So now let's discuss each of these measures in a little more depth, starting with the measures of center. I'm sure all of you know what the mean is of the average of all the values in a sample. The average of all the values in a sample. How do you measure the mean? I hope all of you know how the mean is measured. There are 10 of the first. You have to do is you have to add up all the 10 numbers, and you'll have to divide it by 10. And your represents the number of samples in your data set. But since we have 10 numbers, going to divide this by 10. This will give us rich. To better understand the measures of central tendency, let's look at an example. Now the data set over here is basically the car's data, and it contains a few variables, or something as per gallon, cylinder type, displacement, horsepower, and roll axle ratio. Right, all of these measures are related to cars. So to use descriptive analysis, you're going to analyze each of the variables and data set, the mean, standard deviation, median, more, and so on. So let's say that you want to find out the mean, or the average horsepower cars among the population of gods. Earlier what you'll do is you'll check the average of all the values. In this case, we'll take the sum of the horsepower of each and we'll divide that by the total. Okay, that's exactly down here in the calculation part. 210 basically represents the horsepower for the first car. That similarly I've just added up all the values of horsepower for each of the cars, and I've divided by 8. 8 is basically the number of cars data set. It's 103.625 is what our mean is. Of horsepower is alright. Now let's understand what median is with an example. Okay, so to define median is basically a measure of the central value of the sum. The median is the middle value. So if you want to find the center value of the mileage per gallon among the population of cars, first what we'll do is we'll arrange the MPG values in ascending or descending order and choose a middle value, right? In this case, since we have 8 values, right, we have 8 values, which is an even entry. So whenever you have even number of data points or samples in your data set, then you're going to take the average of the two middle values. If we had 9 values over here, we can easily figure out the middle value, and choose that as a median. It's an even number of values. Going to take the average of the two middle values, alright. 22.8 and 23 are my two middle values. And I'm taking the mean of those two, hence I get 22.9, which is my median. Alright, lastly, let's look at modus. And what is mode? The one that is most recurrent in the sample set is known as mode. Basically the value that occurs most often, known as more common type of cylinder among the population. All we have to do is we will check the value which is repeated the most number of times. We can be the cylinders come in two types. We have cylinder of type 4 and cylinder of type 6, right? Take a look at the data set. You can see that the most recurring value is 61,234. We have 123 we have 3 4-tenders and 5 6-type cylinders. Basically we have 3 4-type cylinders. And we have 6-type cylinders. Alright. Mode is going to be 6 and 6 is more record and then 4. So guys, those were the measures of the center, or the measures of central tendency. Now let's move on and look at the measures of the spread. Alright, now what is the measure? Sometimes. Also, as maldispersion is used to describe the variability in a sample or population, okay, you can think of it as such. So you measure the health of the measure of spreads. You have range, interquartile range, variance and standard deviation. Now range is self-explanatory. It is the given measure of how good or bad the values in a dataset are. The range can be calculated as shown in this formula. You're basically going to subtract the maximum value in your dataset from the minimum value in your dataset. That's how you calculate the range. Alright, next we have interquartile range. Before. Stand watch, please tell us the spread of dataset breaking the data into different quarters. Okay, just like how the median takes the data into two parts quartile, we'll get into different quarters to better understand how interquartile are calculated. Let's look at a small example. Now, this data set basically represents. It's the marks of hundreds of students ordered from the lowest to the highest goals, right? So the quartiles lie in the following ranges. First quartile, which is also known as Q1, it lies between the 25th and 26th observation, right? So if you look at this 25th and the 26th observation, how you can calculate Q1 first quartile is both values are 45. When you add them up and divide them by 2, you still get 45. The second quartile, or Q2, is between the 50th and the 51st observation. You're going to take the average of 58 and 59, and you will get a value of 58.5. Now this is my second quarter, third quartile, Q3, between the 75th and the 76th observation. Here again, we'll take the average of the two values, which is the 75th value and the 76th value, right, and you will get a value of 71. Alright, so guys, this is exactly how you calculate the different quarters. Let's look at what is interquartile range. Interquarterly data quarter. Now the range is created by subtracting 123 SQ1 is your IQR. So you'll do 2 3 months 1. Now, how each of the ends or each quartile represents 5%. So guys, I hope if you are clear with interquartile range and what are quartiles. Now let's look at variance. Joe, that was a period value, okay. CLI, the vanes, the variable weights can be calculated by Miller at your X basically represents any data point in your dataset, and is the total number of data points in your dataset, and X bar is basically the mean of data points. Alright, this is how you calculate variance. Parents is basically computing the squares of deviations, okay? That's why it says a squared. Then now let's look at what is deviation. Deviation is just a difference between each element from OK, so it can be created by using the simple formula. Basically present a point U is the CLI. Have you heard the vision? Population variance? Variance are very specific to whether you're calculating the variance in your dataset or in a dataset. The only difference between population and sample variance. The formula for population variance is pretty explanatory. Xi is basically each data point. Mu is the mean of the population. N is the number of samples in your dataset. Alright, let's look at sample variance. A sample variance is the app. U squared differences from the mean, right? Your XY is any data or any sample in your dataset. X bar is the mean of your sample. Right? It's not the mean of your population, the mean of your sample. And if you notice in here is smaller n is number of data points in your sample, and this is basically the difference between sample and population variance. I hope that is clear. I mean, standard deviation is the measure of dispersion. The set of data from its mean, alright, so it's basically the deviation from your mean. That's what standard deviation is. How to bet on how the measures of spread are calculated. Let's look at a small use case. Let's say the net has 20. They have numbers 92, 54 and so on, as shown on the screen. What you have to do is you have to work out the standard deviations. But in order to calculate the standard deviation, you need to know the mean, right? So first you're going to find out the mean of your sample set. So how do you calculate the mean? To add all the numbers in your data set and divide it by the total number of samples in your data set. So you get a value of 7 here. Then you calculate the RHS of your standard deviation formula. 9254 and so on. So from each data point, you're going to subtract the mean and you're going to square that, alright. So when you do that, you will get the following result. Basically get this for 25 for 925 and so on. Finally, you will just find the mean of the square. Difference is alright, so your standard deviation will come up to 2.983 once you take the square root, because it's pretty simple, it's a simple magic technique. All you have to substitute the values in the formula. Right. I hope this was clear.